Hey, what's going on, guys? In this video we are going to take a look at rules of inference. Rules of inference is basically we take a set of premises and deduce into a final conclusion. Now let's look at this one. Here it says if it rains I will get wet. It is raining, so finally we will end up with I will get wet. Now if we look at an example like this, we are going to have like R arrow W, and if you have R like this, the final result is going to be this one, that's W right here. Okay, here this is our premise, and this is our conclusion. Okay, now let's go to the next one. Here it says a set of premises P1 P2 to Pn prove some conclusion Q in an argument, and an argument is valid if the premises logically entail the conclusion. If it, like for example, if it's stopped in the middle or there's no conclusion, it means this is invalid. This one we can write this one as also R arrow W and R, that will result in W. This is always true. That's why we call this tautology. Okay, now let's look at some laws. The first law is modus ponens. In the short form you can see it like, you can write it as MPP, and this one says if you have P arrow Q and P, it's basically going to become Q. You can think this one like if you stick it in an arrow for something, and that's going to be the final end. And modus tollens says if you have P arrow Q and not Q, the result is going to be not P. Okay, that's what modus tollens says. You can also prove the same thing using contraposition. Contraposition is negation and opposite, like you take the negation of this one not Q and then not P, and if you apply the same thing you will get the same answer. Okay, that's what modus tollens says. For modus tollens the shorthand form is MTT. You can write it as MTT. Now let's look at some other laws. The next one is hypothetical syllogism. Hypothetical syllogism is basically says P arrow Q, Q arrow R, that is equivalent to P arrow R. It's basically like if we put P, and let's say we have P, and let's say here we have Q, and here we have R, and it's like directly jumping from here to here, right? That's how it's derived. Like that's how it always comes. Now the next thing is disjunctive syllogism. Disjunctive syllogism says if you have P or Q and not P, like if P or Q is true and there's not P, it means P and not P cancels, then Q is the true thing. So Q is going to be the final result for disjunctive syllogism. For hypothetical syllogism you can write the shorthand form HS. For disjunctive syllogism you can write it as DS. Okay, because we are going to need these things, shorthand forms, to when we do the proof questions. We have to show each step which law we are using, so it's always helps us to keep the shorthand form HS, DS. The next thing is addition. Addition says if P is true, then P or Q is also true. And the simplification says if P and Q are true, then P is true, and also you can say Q is true. And the conjunction says if you have P is true and Q is true, then P and Q is true. Okay, these are the laws. Now let's look at some examples from that. Here we have an exercise. Here what we are going to do is we are going to take a set of these premises and we are going to derive a conclusion from that. We have to use all of them and derive a final conclusion. Now let's try the first step. Here you can see we have R and R arrow D. As we seen before, we can use the modus ponens. Modus ponens says if you have P arrow Q and P, you can deduce this one into whatever the thing that's arrow stick into, that's Q right here. For this question, R arrow D, so we can deduce into D, right? We are using 1 and 2, and we use the modus ponens law. Now we have D left. We have to use the 3. We have used 1, 2, and we have 3 left. 3 again, you can again use the modus ponens. That is going to become like we have D and D arrow not J, So you can see D goes away, whatever the arrows stick into, that's going to be the final result. So not J is going to be the final result. That's based on 3, 4, and this is modus ponens. Okay, now we can use hypothetical syllogism. By hypothetical syllogism, what you can do is 2, 3. We have R arrow D and D arrow not J. So by hypothetical syllogism, you can see that we've seen that if you have R, D and not J, it's like jumping from here to here directly. So we can write this one as R arrow not J. R arrow not J. Okay, that's our hypothetical syllogism. Now the next thing is again modus ponens. We can apply modus ponens for, we have 4 here, and we used, this is coming from 2 and 3. 2, 3 hypothetical syllogism. We have first one left, and we have first one and fourth one is remaining. So we have to combine these two together. We have R and R not J. We can use the modus ponens like R and R. These are whatever the R stick into arrow, that's going to be our final end, that's not J. So here you can see there are more than one way. MPP, I applied MPP for 1 and 4. So more than one way to derive the same answer. Okay, same answer, not J is the same answer. Okay, now let's look at another example. Here we have 3 premises. We are going to deduce this one into final end. Okay, let's go to the fourth one. So fourth one is, here you can see this 2 and 3. 2 is S arrow T and 3 is not T. So here I can use modus tollens. Modus tollens says if you have P arrow Q and not Q, that's going to result in not P. And here we have S arrow T and not T, that's going to result into not S. Okay, not S. Not S. Here this is for 2 and 3, modus tollens, MTT. Now for 5, here we can apply contrapositive for 1. If we apply contrapositive for 1, we negate this one and flip around. So this is going to be not S and L arrow not R or not F. Okay, so this is one contrapositive. Now the sixth thing is, we are going to use the De Morgan's theorem. De Morgan's theorem says if you expand this not into inside, that's going to become, like if you have and, that's going to turn into or, and if you have or, that's going to turn into and. Now let's go ahead and do that. So for 6th step, this is going to become not S or not L, and the next thing is going to become not R or not F. And here we applied De Morgan's theorem. Now here we can use the double negation. Double negation is, when we have double negation, it's going to cancel each other. So we can simplify that one. The first one, we don't have any double negation, so we just keep it as it is, not L. And this one will turn into R and F. Okay, this is double negation 6, double negation. We apply double negation for the 6th one. That's how we got this one. Now the next thing is, we are going to do the addition. Addition for, we can do the addition for 4. Addition, because if you have not S, if you do the addition, that is not S or not L. We can write this one like this. This we apply addition for 4. Addition. Okay, I'm going to continue in the next page. So we derived addition. Then we have for 7 and 8. For 7 and 8, I am going to use Modus Ponens. Modus Ponens says when you have same thing, and if you have stick in arrow something, this is going to be our final end. Whatever the value the stick in the arrow here, R and F. So for 9 we can write R and F directly. R and F. We applied Modus Ponens for 7 and 8. Modus Ponens. Okay. Finally, by simplification, if we apply simplification to 9, we can just derive R. 9 simplification. And that's our final answer. And that's it. I hope you guys find this video helpful. Thanks for watching. And if you are trying to learn discrete mathematics, there are a bunch of videos in my playlist. I hope you guys watch that too. And don't forget to subscribe. See you next time.